Welcome students into the series of lectures on LangGraph. And in the series of lecture on LangGraph, this is our first video where we are creating an agent, and the agent that we are creating is a reflection agent. What a reflection agent is capable of? A reflection agent is capable of to be intelligent. Actually, it is capable to think, it is capable to reflect, it is capable to improve, it is capable to evaluate. So basically, when you implement a large language model into LangGraph, it becomes an intelligent workflow, an intelligent LangGraph workflow. So we are moving away from the static workflow to a agentic workflow. And this is the first session where we'll actually do the implementation and create our first agent with the help of LangGraph. So without any delay, let's move into the implementation of our agent, the reflection agent, with the help of LangGraph. But there are certain prerequisites that you have to understand. The first one is that you have to choose your model. Currently, I'm choosing a model. I'm choosing a Grok model because it is freely available. I don't have to pay for it. Otherwise, I would have gone for a better model with the help of OpenAI or Gemini. It is up to you. For this session, it is sufficient that we'll choose a model where we can get our data, we can use our LLM easily and freely. For that, you need something. What you need is the API key. Otherwise, you cannot use any model, whether it is Open AI model or it is a Gemini model. What you need a API key. For that, let's go to the Grok homepage. This is Grok homepage. Go directly to API keys. You have to create your own account. Go to the API keys, create your API key. I'm creating an API key, say LLM land graph reflection agent test. Before you hit submit, remember to copy your API key because this would be display only once in the whole lifetime. So copy it. Now paste your API key here. I'm going to delete all my API keys so you won't be able to use any API key when the video would be uploaded. So this is my API key. Now, if you would have been using OpenAI, there is a different way to fetch API key, but it is a paid one. If you're going for Gemini again, there is a different way to fetch the API key, but again, it is a paid one. Okay. Currently, it is a paid one. Sometimes they provide free API keys. Now, what you need to do, the second prerequisite is you have to use a LangChain library. From the LangChain library, you will import a specific class for your Grok model, that is ChatGroq. This is a specific class. If you would have been using OpenAI LLMs or OpenAI model, then there's a different class that you have to import. The name of the class is chat OpenAI. Perfect. Now, so you import ChatGroq for Grok, you import chat OpenAI for OpenAI. For Gemini, it is different class that you have to import. But from LangChain, not from LangGraph. This is not a class which is written inside the LangGraph. It is written in the LangChain. LangChain was the precursor of LangGraph. So when they created LangGraph, they didn't create any class inside the LangGraph which we can use to invoke the intelligence or invoke your large language model. All the classes are written in the LangChain, not LangGraph. So you have to use this LangChain libraries. And for every LLM, there is a specific class written inside the LangChain. Okay. So you will import this class. Now, when you will initiate this class, you need to provide two parameters, the models and the API key. The model and the API key. Perfect. Now, this is the object that you have created. This is the specific format I would suggest that you should create your object for your class specific to the specific model. So this is the particular object that we have created for ChatGroq model. What do you have to provide? You have to provide the model name. You have to provide the API keys. Once it has been provided, the next function that you call is invoke. Invoke is the function which will actually invoke the large language model in your LangChain. This particular function of invoking a large language model is only available in LangChain. It is not available outside the LangChain. So is it that you cannot invoke or use any large language model outside the LangChain? You can, for example, use bytes, not LangChain. Then what I'll do, I'll use sdk.model, then result, And this is the specific call that I'll do in bytes. If I'm using bytes, if I'm using OpenAI, there is a specific way to fetch or connect your large language model. Currently, we are talking about LangGraph and LangChain. And for LangGraph and LangChain, you have to use the function LLM.invoke. No other function need to be used or required. So I'm storing the response in a variable response. But see what I'm saying? I'm saying that please give me the content of the response. Why I'm not asking for response? The problem with the response is that it is not very much structured. See, it is saying AI message content. I'm only interested in content. So what I'm asking for the content. So it is providing me the full detail for the question that I have asked. The next, the world of LangGraph. We'll now jump into directly how to implement, how to invoke large language model in our LangGraph workflow. Definitely, we have to use certain libraries. These are certain libraries that we have to import. Please understand, not all libraries are associated to LangGraph. Only these class and marker is associated to LangGraph. See, we discussed in the last session that state graph is the only class in the LangGraph library or module which understand the nodes, the edges, the workflows, the components of the workflow. Start and end are the specific marker which tells the entry and the exit point of your workflow. TypedDict doesn't have to do anything with LangGraph. ChatGroq, I already mentioned that this is a LangChain class, not LangGraph class. Then image and display, we already know that we already discussed in detail in the last session that it has nothing to do with LangGraph. OS, we all know it is related to operating system. Okay, let's import all the libraries. So I'm importing all the libraries. Now, I'm again initializing my large language model with the help of the class that is ChatGroq, and I am initializing my object. And the parameters are models and API key. Everything worked fine. Now, after this, what I have to do, I have to implement the workflow that we did in our first session of implementation of the workflow. So the first thing that I have to do is to define the state. And please note that you can define the state in two ways. One, you can create the dictionary or you can create a class and inherit TypedDict class. It is a special type of class which make your state a perfect dictionary that can be used without any data error. Or you can say it can handle the data error in your code properly. Very structured state dictionary would be created. Perfect. Now, what we discussed in the implementation of our first workflow in LangGraph, that when you implement the node, there are two steps for the implementation of the nodes. The first is you have to define the node. So now we are defining node 1, node 2, node 3, so on and so forth. Now, when I'm defining the node, what is the compulsory step? The compulsory step is that you pass the state and you return the state. First of all, see that when I'm passing the state, I'm fetching state question. So why we am fetching the state question? Because when I am creating my initial state, I have provided a question. Explain India to me. This is the question I would be providing to my state, to the initial state. This is a question that I am mentioning in my initial state. So it will fetch the question from the state dictionary. Now, next step is to invoke the large language model, invoke the intelligence. I'm asking my large language model to give the answer for the following question. It will fetch a response. And please understand, I'm using what? A class, an object, a function from the LangChain library. This is the function, this is the object, and this is the class from LangChain library. I'll get the response. Understand, I cannot use the response directly. I would use response.content. I'm saving it inside the answer key of the state dictionary. I'm returning the state. I'm returning the state to whom? I'm generating answer. I'm generating answer in this node. I will provide the state to the next node, which will evaluate the answer. So the next node is what? Evaluation of the answer. It is getting the state from generate answer, the previous node. It is taking the state question, which we have already defined as explain India to me, and then I'm fetching state answer, which I'm getting as a response in the previous node. I'm getting the answer. Now I'm invoking my large language model again with the question and the answer because I want to evaluate the answer and give me the score between 1 to 10 and also provide me the feedback. I will store that response in a response variable. I'll fetch the content of that response in the output. From the output, I'm fetching a digit. Why? Because I need the score. If the score is 9, I'll do something. If the score is 8, I'll do something. If the score is 6, I'll do something. Right? What I'll do if the score is greater than 7, then I'll say the response is good. Otherwise, improve. Where I would be defining that in the decision function. But please understand, I'm doing something which is try and accept. Why? So we all know that the large language model will do some mistake. We all know that. This is our daily routine to discuss something with ChatGPT or Gemini, and we know that they cannot give you the proper response. So what if they don't provide you the score like 7 or 8? If they don't provide you the score, then this will create an error because you're trying to fetch a digit from a response where there's no score given. So what I'm doing, I'm doing an error handling with the help of try and accept. Try and accept. I'm saying if this will throw you an error, then give a default score of 5. Definitely, I wouldn't be using that response. The reason being, the score given is what, 5, and in the decision function, I will say that improve the response. Perfect. See, so I'm also printing the output, which is the feedback, which is given by my LLM as a response to see what kind of a feedback it is providing, what kind of a score it is providing. This is not a compulsory step. You can delete this. It is completely up to you. Again, it is returning the state. Now, if you remember, what we have to do, we have to generate the response, evaluate the response, then do a decisioning, and then improve the response. So I need a node which says improve the response. So let's improve the response. How would I improve the response? By the help of state function, I'm taking the state question again and I'm asking the model to improve the response for this specific question. So it'll get the answer, it will get the feedback, and then it is storing the answer, the new answer, in the state dictionary with the help of response.content. With the help of response.content. One thing I'm doing, I'm adding the iteration. The reason I'm adding the iteration is because I want to know how many iteration it took to improve the answer and reach to the final version of the answer that we'll see. Okay, perfect. And that's why I'm asking it to print the iteration, actually the final iteration. Till now, everything related to node has been defined. In the node, what we did, please understand what we did in the node. We haven't written the human defined functions to create the answer or generate the answer. It is LLM which is generating the answer. We are not evaluating the answer. Human is not there to evaluate the answer. It is the LLM which is evaluating the answer. So you're not writing any function to evaluate the answer. Even in improve the answer, you are not writing any function to improve the answer. It is the LLM which is improving the answer, right? So that is the difference between the static nodes and an intelligent node that you have defined right now. After that, whatever we'll see, it is a basic LangGraph code. There is nothing fancier that will happen now after this stage. Only in the node, you will invoke the intelligence with the help of large language model. Okay. Then what we have to do, we have to build the graph. So we can only build the graph with the help of class state graph, which is a very special class inside the land graph. This is the only class which understand your nodes, your edges. So I'm initializing the object for this class and the name of the object is graph. Before that, let's run all the cell. So I'm defining the state. I'm defining my node for get answer. I'm defining my node for evaluating the answer. I'm defining my decision function. I'm defining my node to improve the answer. Now I'm building the graph. Okay, no error. Perfect. Now, once the graph is created, when the graph object is created, what I have to do, I have to add my nodes. I've added the nodes. I've added the edges. I have added the conditional edges. I've added the all defined edges or requisite edges. Let's add it. Okay. What is the important step after that? You have to compile everything. Otherwise, the graph will not understand. The graph will understand what is nodes and edges, but they will not talk to each other. So what we need a compilation that all nodes and edges will talk to each other. So that is a compilation. Now, if you want to check in a very simple way that whether you have created the correct workflow, You will use display an image. We discussed about this cell in detail, in thorough detail in last to last session. So this is your workflow. Please check your workflow is correct or not. The important point. You have to define your question. You defined your question. It could be explain India to me or explain anything to me. What you're throwing? You're throwing an empty string, feedback empty string, score is 0, iteration is 0. These two has to be integer, these three has to be string. Why? Because when you defined your state with the help of TypedDict class, question has to be string, answer has to be string, feedback has to be string, score has to be integer, iteration has to be integer. Perfect. So this is my initial state. Where I'll pass this initial state. I'll pass the initial state where I have compiled my graph, in the app. So app.invoke, passing my initial state. It will take some time because you're connecting to a large language model. Which large language model? Grok. So see, I'm running the agent. This is the last. So it is giving the feedback. And after the feedback, it gave the score of 9 out of 10. And because the score was greater than 7, it is giving me the final answer. Even in the before the final answer, it is giving me the feedback that what are the strength, what are the weaknesses, what are the suggestion for improvement, and this is my final answer for my question that explain India to me. Okay, so this is the complete implementation of an agent with the help of LangGraph. So this was a very simple implementation of agent in the LangGraph workflow. In the next session or the next to next session, we'll discuss how we can make a multi-agent workflow. Please understand there is a problem in this. So the problem is we are using the same LLM. We are using the same model to generate the answer, to evaluate the answer, and to improve the answer. What if I need a different critique model? I want OpenAI to improve the answer. I want to play with different large language models. To generate the answer, I would use Grok. To evaluate, I will use OpenAI. To improve, I would use Gemini. Can I do this? And this is what we want to discuss in one of the session, that how we can create a multi-agent workflow or multi-agent chatbot or a multi-agent system in LangGraph. Okay, with that, I will pause here. Thank you. Have a nice day.